Differential relays under unit 3 of switchgear and protection. So the course outcome of this session is knowledge on current differential relay and voltage differential relay. So the objectives of this session is differential relay principle of operation, working of current differential relay, working of voltage differential relay. So this is session number 29, differential relays. In this session we are discussing on current differential relays and also the voltage differential relays. So as we know that relay, it is an arrangement which sends the abnormal condition of the system and it will give signal to the circuit breaker in order to go for initiation of action. So for the previous sessions, whatever we discussed, the relays relied on excess of current. That is, whenever the current exceeds more than the pickup value, that is called an excess current. So for their operation, so then it will start its operation. So therefore we can call most of the relays relied on excess current for their operation. So the excessive current, overcurrent relays, they are comparatively less sensitivity. Sensitivity, it is one of the parameter of or one of the requirement for protective relays. So these relays are less sensitive. So the distinguish between heavy load currents and minor fault conditions, it is less. So in order to overcome these difficulties, so in order to improve the sensitivity of the system or in order to improve the sensitivity of the relay, in order to overcome these difficulties, differential relays are used. So that is how the differential relay will come into the existence. A differential relay is one that operates when the phase difference of two or more similar electrical quantities exceeds the predetermined value. So therefore the differential relays will be operating when the phasor difference of two or more electrical quantities, same electrical quantities, exceeds the preset value or the predetermined value. So if it is less than the predetermined value, again the pickup value will come. So the differential relay will not function. If it is more than the preset value or the predetermined value, so then the differential relays will be operating. The fundamental systems of differential is also called as a balanced protection. One, it is called as a current balanced protection and the voltage balanced protection. So this is the schematic arrangement for current differential relay. So let us assume we are protecting or we want to protect the alternator winding. So therefore two CTs, CT1 and CT2 are connected on either side of or either sides of the alternator winding. So this is the current ratio for CT1. Two similar, the same current ratio we are using for CT2, and these two are connected with at equipotential point. The operating coil of overcurrent relay is connected. The construction part is like this. A pair of identical CTs, current transformers, are fixed or fitted on either sides or either end of protected. The secondaries of CTs are connected in series. They carry the induced currents in the same direction. The operating coil of the overcurrent relay is connected across CT secondary circuit. The differential relay compares the current at two ends of the alternator winding. So since it is a differential quantity or the differential relay will be comparing the currents entering and leaving at the armature winding or alternator winding. Under normal operating conditions, suppose the alternator winding carries a normal current of 1000 amperes. So the same 1000 amperes will come, and if the turns ratio is 1, so the 5 amperes of current will flow through the primary, CT1, and same amount of current will flow through the CT2. Then the currents in the two secondaries of CTs are equal. Whenever the currents are equal, now the amount of current that is passing through this relay operating coil, it becomes 0, because so this is the current entering and this is also current entering. These two will flow in the opposite direction. Whenever the opposite direction flows, the difference amount 5 minus 5, so 0 amperes of current will flow through the operating coil of overcurrent relay. Whenever the 0 current flows through this relay operating coil, now the relay, it is said to be inoperative. So when it is come to the working part of current differential relay, under normal operating conditions, the alternator winding carries normal current. The currents in the two secondaries of CTs are equal. Whenever the currents of the two secondary CTs are equal, no current will flow through the differential relay. When we don't have a differential relay current, the relay, it is said to be inoperative, or relay, it is said to be inactive. Let us assume if a ground fault occurs on alternator winding. So whenever the ground fault occurs on the alternator winding, the two secondary currents will not be equal. The current flow through the operating coil of the relay, causing the relay to operate. The amount of current flows through the relay, it depends on the type of fault on the alternator winding. So when you have got a fault, now the difference amount of current flow through, whenever the difference amount current that is flows through the relay operating coil, and that too, if it is more than the preset value or the predetermined value, now the relay coil will be operating. Whenever the relay coil get operating, it initiates action for circuit breaker to open. So let us see if it has got a few disadvantages. The current balancer system has got drawbacks. One, if the relay is sensitive, then small differential current flowing through the relay may cause it to operate. So even for a minor faults, even for a minor difference, since it is very sensitive, even for a minor difference, the relay will be in action. So we are using the pilot cables in order to connect CT1 and CT2, which are connected on either sides of alternator winding. So these pilot cables have a capacitance. It causes inaccurate operation or incorrect operation. The accurate matching of current transformers cannot be achieved. So we should match the current. So since the existence of capacitance in the pilot cable, so you cannot go for accurate matching. So these are all the few drawbacks. It is very less sensitive. The pilot cables possess some value of capacitance, and accurate matching is not possible. So these are all a few drawbacks or disadvantages of current differential relay. So when it is come to the voltage differential relay, so this is the second of its kind, differential relay. So here also we are using two similar current transformers which are connected on either end of the element to be protected, and the two CTs are connected by means of pilot wires. The secondaries of current transformers are connected in series with a relay in such a way that under normal conditions their induced EMF are in opposition. There the current directions are opposite. In case of an voltage differential relay, the induced EMFs are in opposite. So this is the schematic arrangement for voltage differential relay. So we will see the operation for the voltage differential relay. Under healthy conditions, the equal currents I1 and I2 will flow through the primary winding. The secondary voltages of two current transformers are imbalanced and against each other or opposite to each other. Therefore, no current will flow through the relay operating coil. So there will be no amount of, current that is flowing through the operating coil. So whenever there will be no current, that say, since the induced EMFs are 0, so there will be no current flow through the relay operating coil. Whenever there is no current that is passing through the relay operating coil, the relay, it is said to be inoperative. Let us assume when a fault occurs in the protected zone. So whenever the fault occurs in the protected zone, the currents in the two primaries will differ. So there is a difference of currents in the primary, whereas in healthy condition, when you don't have any faults, I1 is equal to I2. When you got a fault in the protected zone, I1 is not equal to I2. Their secondary voltages will no longer be in balance. So in previous cases, whenever I1 is equal to I2, the voltages are said to be in balance. When you have got a fault, when the condition is I1 is not equal to I2, when I1 is not equal to I2, so there will be no secondary voltages. So whenever there is no secondary voltages, right? So the system is no longer under the balanced condition. The voltage difference will cause a current to flow through the operating coil of the relay, which closes the trip circuit. So here also, whenever you got a voltage difference, the difference in voltage will lead to the flow of current through the relay operating coil. Whenever the current that is passing through the relay operating coil, and that too, if it is more than the preset value or more than the predetermined value, the relay will be activating or actuating. Whenever the relay gets activating or actuating, it closes the trip circuit. So even this voltage balanced system has got drawbacks. One, the multi-gap transformer construction is required in order to achieve accurate balance between current transformer pairs. So the multi-tap transformer, so this is essential in order to balance the accuracy between the two CTs or the CT pairs. The system is suitable for protection of cables relatively short length due to the existence of capacitance in the pilot wires. So we are using to connect two CTs, CT1 and CT2, and these CT1 and CT2 we are connecting through the pilot wires. So these pilot wires will possess some value of capacitance. So it has got few drawbacks. One, it should have a multi-tap transformer, that is essential in order to go for accurate balance of two CTs. And again, so it should possess some value of capacitance. So this capacitance, if you neutralize, so then it is possible to go for the voltage balance system. So the disadvantages of this voltage balance system can be overcome by using translay relay. So translay, it is a modified version of balanced voltage system. So by using this, so we can overcome the disadvantages like multi-tap transformer and the effect of capacitance. So this is in this session we are mainly focusing on current differential relay and voltage differential relay. The operating principles of both voltage differential, basically why we are going for differential relay, because of overcurrent relays are less sensitive. In order to go for say more sensitivity, so we are depending on the differential relays. So differential relay, whenever the it will have a comparison between the currents entering or leaving. If you got any difference, so then the relay will be starts functioning. So we will take some sample questions. That assessment number 1, 1 VA relay dash sensitive than 3 VA. So the options are less, B more, C both A and B, D none of these. So the 1 VA relay always more sensitive than 3 VA relay. So therefore the solution for this is B. The backup protection functions when dash. Options are fault occurs, B relay fails, C circuit breaker fails, D primary protection fails. So we have got two types of protection. One is primary protection and the second is the backup protection. So this backup protection, it is called as a second line of defense. So the second line of defense will come into the picture only when the primary protection fails or the first line of defense fails. Therefore, the solution for this is D. The backup protection functions when the primary protection fails. So the third assessment here is a differential relay operates when dash. The options are A excess current, B excess voltage, C phase difference, D none of the above. Basically differential relay will be operating when the phasor difference of two or more electrical quantities or similar electrical quantities exceeds the predetermined value. So therefore the solution for this is C. A differential relay operates when phase difference. Fourth, a voltage differential relay drawback can be overcome by dashed relay. The voltage differential relay drawbacks can be overcome by dashed relay. The options are A current differential, B induction type relay, C overcurrent relay, D translator relay. So the voltage differential relay has got few disadvantages. One, in order to go for accurate adjustment, we need to have a multi-tap transformer. And second is, so the existence of capacitance by the pilot cables. So this can be overcome by using a translator relay. So therefore the solution for this is D. The voltage differential relay drawbacks can be overcome by using translator relay. So before concluding this session, so the objectives of this session, once again I repeat. So we will see the principle of operation of a differential relays. Second, working of current differential relay, and the working of voltage differential relay. Say after the session, the students, the CO attained is the students are able to, or students will gain the knowledge on differential relay principles, current differential relay, and also the voltage differential relay. So we are going for differential relay because of less sensitive by the current differential relays, what we are discussing in the previous sessions. And in order to overcome these difficulties, so we are going for differential relays. So basically the differential relay is one that operates when the phasor difference of two or more similar electrical quantities exceeds the predetermined value. So we have got two. One is a voltage differential relay and current differential relay. So in this session we have taken a few assessment also, and we have discussed the solution for the assessments and the disadvantage of voltage differential relay can be overcome by using transfer relays. And this is our team headed by Srimati D. Aruna and Dr. K. Tippeswamy. Thank you.